All right, here we go. Our final answer keys of the year. I think this is going to be kind of a longer video, so you are more than welcome to just skip around to whichever problems you need. You don't need to watch the full entire video. Um, but if you are kind of feeling stuck on any one problem, feel free to go there and just kind of listen to that explanation. And this PowerPoint will also be posted in Teams if you just want kind of the quick synopsis and go scroll through and check all of your answers really quickly. So this is just kind of an additional resource for you. So our first assignment of the week was page 737. So here's the first few problems. We were doing 6 through 20 even. So on number 6, it asks us to find the surface area of the sphere with the given diameter or radius and leave our answer in terms of pi. So for number 6, we're given a diameter of 30 meters. We know that our radius from that would be 15. We know our surface area formula is 4 pi r squared. So I'm going to plug in 15. 15 squared is 225, and then 225 times 4 gives me 900 pi meters squared. For number 8, the diameter is 32 millimeters, which means the radius would be 16 millimeters. The surface area, 4 pi r squared. 16 squared, I believe, is 256. I should have written that one down. And then multiply that by 4, you get 1,024 pi millimeters squared. In number 10, it asks us to find the surface area of each ball, and again, leave our answers in terms of pi. So once again, they give us the diameter of 68 millimeters. Half of that is 34, so that's my radius. So my surface area is 4 pi r squared. So I'm going to do 34 squared and multiply that by 4, which gives me 4,624 pi millimeters squared for the surface area. On number 12, the diameter was 2 and 1/16 inches. So I turned that into a fraction for my radius, which was 33 over 32 or 33 30-seconds. The other way that you could do it is that a diameter of 2 and 1/16 is the same thing as 2.0625, and then divided by 2, I believe that's like 1.0312 something. So you could also just use a decimal. So I have mine in simplified fraction form just because that's kind of how my brain rolls on that. But if you used a decimal instead of a fraction, I think at the end you should get 4.25 approximately times pi. And if you had multiplied that out times 3.14, that would be like 13 point something. So at the end, we should get the same approximate answer, but we may have differing forms, and I'm okay with whichever form if you got the 4.25 pi or the 13.357 or whatever your final answer was. It should just be pretty close to what I have. On number 14, it says to use the given circumference to find the surface area of each spherical object. So in the PowerPoint that I posted for you guys earlier, I mentioned you always kind of want to go and find the radius first. And then once you've found the radius, then you can work your way towards finding the surface area. So these ones are just kind of weird because they don't actually have pi in them, right? So we know for number 14, if the circumference is 27 inches, so I kind of wrote my little equation over here for number 14. If the circumference is 27, we know that the formula for circumference is 2 pi r. So in order to get r by itself, I'm going to set up this equation. The circumference 2 pi r is equal, in this case, to 27. So then I want to divide both sides by 2 pi to isolate r. And because there's not a pi to nicely cancel out on this side, I actually do have to plug that into my calculator, and I get this r equals 4.299 approximately. So then I can plug that into my formula for surface area, which is 4 pi r squared. And that gets me, it says to round to the nearest whole number, so that gets me approximately 232 inches squared. On number 16, same exact process. I know the formula for circumference is 2 pi r, so I'm going to replace c, for circumference, with 2 pi r and make a little equation out of it. 2 pi r equals 22. Again, I didn't show it the way I did over here, but we need to divide both sides by 2 pi, isolate r, get the radius by itself. When I divide 22 by 2 pi, I get 3.503 approximately. And when I plug that into my formula here, 4 pi r squared, I get approximately 154 inches squared. And remember, we're saying to the nearest whole number. In 18 and 20, we're trying to find the volume of each sphere. And then it does say to give each answer in terms of pi and rounded to the nearest cubic unit. So I'll take either answer that you have. For number 18, it gave us a diameter of 12 centimeters, which means our radius is 6. So we're going to do 4/3 pi r cubed is the formula. Be careful because, again, as I mentioned in the PowerPoint, that a lot of people will just kind of get in the groove of the surface area and forget to cube this. So that should actually be 4/3 pi times 216. If you have 4/3 pi times 36 as you're showing your work, you may have squared it instead of cubed it. So when I multiply those together, 4 times 216 gave me 864, and then when I divide that by 3, I get this 288 pi centimeters cubed. So that's my answer in terms of pi. And then when I multiply it out times 3.14, I get approximately 904 centimeters cubed. And that's, of course, a rounded value there. On number 20, pretty convenient, they finally gave us just the radius, so we don't have to do anything. We can just use 8. So 4/3 pi r cubed for my volume. 8 cubed is 512. So in terms of pi, this is 2048 divided by 3, and that gives me a decimal. So I just went ahead and left it as a fraction because it's a more precise answer to leave it is as a fraction. But if you plug that into your calculator, you might have gotten 282.67 or 0.7 or 66667 or something like that times pi. And then when you multiply times 3.14, that becomes 2,049 centimeters cubed. So it's actually pretty close since we have 3 on the bottom and 3.14. They almost cancel each other out. It's just a little bit bigger at the top. So again, either of these answers, or even the decimal version of this one, I would take. On 23, they tell us that the sphere has a given volume, and these ones are a little bit tricky, so if you got these, good on you. If not, go ahead and listen up. We want to find its surface area to the nearest whole number. So in 23, they give us a volume of 900 inches cubed. I know that my volume formula, this is literally just like the formula, right? 4/3 pi r cubed. So I'm going to replace what I know. I know that my volume is 900 inches cubed. And that's actually all I know at this point. So now I'm going to try to simplify and get r by itself. So I multiply both sides by 3, and that way it cancels out the 3 in the denominator down here. So now I have 2,700 equals 4 pi r cubed, and then I had to go all the way up here. Oh, and I think it kind of cut out that I had divided both sides by 4 pi here. So when I divide both sides by 4 pi, that gets r cubed by itself on one side. And then over here, that's where I got this value of 214.968. And again, that's an approximation. So then to get r cubed by itself, I have to take the cubed root on both sides. So every calculator is going to look a little bit different, but you do need to take the cubed root and not the squared root. So this should be approximately 5.99 for the radius, approximately. So then to find the surface area, now that I found my radius, I can just plug it into the formula, 4 pi r squared, and I'll get approximately 451 inches squared. If you had rounded this to like 6.0, or if you have a slightly different number, you may have a slightly different whole number approximation here, maybe 450 or 452, but you should be pretty close to that 450 something, or maybe like 448 or 449 inches squared. 24, same process here. So I have my volume formula, 4/3 pi r cubed, but I replaced volume with 3,000 because that's what I have up here. I multiplied both sides by 3 so that I can cancel out the 3 in the denominator here. And I did actually show my work of dividing both sides by 4 pi here. So that's nice because that cancels out. And then I have to plug this portion over here, 9,000 divided by 4 pi, put that into my calculator. And that gave me 716.56 approximately. Take the cubed root to get r cubed by itself to get it to be just r. I found r was approximately 8.949, and that, again, that's an approximation. Plug it into my surface area formula now, and I got the surface area was approximately 1,005.7535, which is around 1,006 meters squared. All right, so for number 30, it tells us that we have a sphere that is fitting snugly inside of this cube that has 6-inch edges, right? So when it asks us to find the space between the sphere and the cube, it's kind of saying this like space that surrounds the sphere, right? So I started by finding the volume of the cube, which was 216, because it's the base would be 6 by 6, 36, 36 times 6, 216. So the whole volume of the cube is 216. And then since the width of the cube is 6, that means that the radius would be equal to 3. So when I find the volume of the sphere, that would be 4 pi r squared, which 4 pi times 3 squared. And when I plugged that all into my calculator, including 3.14, I got 113.04. So in order to find that kind of extra space surrounding the sphere, I started with the cube and subtracted the sphere, and I got around 102.9 when I rounded inches cubed. So I chose option C there. On 34, this is just like those ones we were just doing where we found the surface area and then found the volume, but now obviously we're going from volume to surface area. We really want to find the radius for each of these. So I'm going to actually do 35 first because I didn't show every step on 34. So in 35, since my surface area is 36 pi, I know that the formula for surface area is 4 pi r squared. So what I'm doing here is I'm essentially trying to get r by itself, right? So when I divide both sides by 4 pi, that cancels the 4 pi's out on the right side here. And it also, pi divided by pi is 1, so that just kind of goes away on that side. So it kind of simplifies out really nicely, right? So now I have r squared on this side and 36 divided by 4, which is 9 on this side. So if I take the square root on both sides to get r by itself, I end up getting that r is 3. And then now that I have my radius, I can just go and plug it all into my volume formula. So 4/3 pi r cubed, 3 cubed is 27, and however you end up simplifying that, I got 36 pi inches cubed. If I go back to 34, it's the same process here. I just didn't show quite as much work. So the surface area, the formula I know is 4 pi r squared, and then my given surface area here is 4 pi. So I actually, when I divide both sides by 4 pi, this is going to get a little messy here, but if I divide both sides by 4 pi, they cancel out on this side and give me r squared, but they also cancel out on this side. So I essentially get this formula that looks like r squared equals 1, right, when everything cancels out. Well, if r squared equals 1, that means that when I take the square root on both sides, my radius is just 1. So that gives me a nice volume where I can just go 4/3 pi r cubed. Well, 1 cubed is just 1, so it's actually just 4/3 pi meters cubed. All right, number 49 can be kind of a tricky one sometimes. So if you got stuck on this, this might be a good one to watch. So for number 49, remember with composite figures, a lot of the time there's not just like one single formula. You kind of have to piece things together in a way that is just going to kind of have common sense, right? So I started by finding my base, and I noticed that there's only one circle that's on the outside of this figure, right? This circle that's on the top is actually inside of the figure because it's kind of inside of that half circle in the cylinder. So if I was thinking of like, if I dipped this in paint, what would be covered in paint? Just this bottom circle and then the lateral area or the outside area of the cylinder and then kind of this half of this sphere that's here. So since my base is 4 pi centimeters squared, right? My radius is 4 pi centimeters squared. My lateral area, 2 pi r times the height, will be 10 pi centimeters squared. That's the lateral area of the cylinder, right? The surface area of the sphere should be 4 pi r squared, but then I went through and just divided it by 2 because really I'm only finding half of the surface area of a sphere. So this half surface area amount that I found here was 8 pi. So I added them all together, 4 pi plus 10 pi, pi plus 8 pi, and that gave me 22 pi centimeters squared. And I just left it in terms of pi for simplicity. For the volume should actually be pretty simple, right? We just find the half of the volume of the sphere and then the volume of this cylinder and just add them together. So for the volume of a sphere, I know that the formula should be 4/3 pi r cubed, but then I went through right here and divided it in half. And technically I should have the whole thing divided in half the whole entire time. It just gets a little bit confusing to look at, so I didn't write it on that first one. So again, I left this as a fraction kind of all the way through, but you could definitely leave it as a decimal if that's easier for you. So 32 divided by 3 was like 10.67. I just hate leaving those repeating decimals there. They annoy me a little bit. So do whatever works for you. So when I go through and continue to simplify this, I simplify it down to 16/3 pi centimeters cubed, and then that would be 5.3 repeating pi centimeters cubed. For the volume of my cylinder, a little bit simpler, right? It's just pi r squared, or 4 pi times 2.5. That volume of that bottom half is 10 pi centimeters cubed. Add those guys together and you would either get like 15 1/3 pi or 15.3 repeating pi centimeters cubed. All right, on to the 11.2 to 11.6 review worksheet. All right, so numbers 1, 2, and 3, and I apologize because I do recognize that my numbering got a little messed up here, 1, 2, and 3. On number 1, we actually had to figure out by ourselves what the slant height was. So you could either use the Pythagorean theorem, right? If our radius is 1 and our height is square root of 3, You could do 1 squared plus square root of 3 squared equals, c squared or l squared or whatever. I noticed though that because that pattern, we have a 1 and a square root of 3 for the legs of that right triangle, that actually is a 30, 60, 90 pattern. So I could just say that the slant height was 2. But if you didn't recognize that, the Pythagorean theorem will work and should still get you 2 for your slant height. So the lateral area, remember, is pi RL. And then the area of the base is just pi. Since my radius is 1, pi r squared, well, 1 squared is just 1. So it's just going to be pi kilometers squared. So when I find my surface area, that's going to be the lateral area, which is 2 pi, plus 1 base, which is pi. So that gives me a total of 3 pi kilometers squared for my surface area. Then for my volume, I'm going to do the base, which is pi, times the height, which is the square root of 3, and divide it by 3. And I actually can't really simplify anything there, so I just left it, since it says in terms of pi in simplest radical form, I just left it like that. But you could, I guess, plug it into your calculator, but since it says to just leave it, I just left it. In number 3, we find out that our perimeter is 160. We know that our lateral area formula is perimeter times the slant height divided by 2. So I did 160 times 25 divided by 2. That got me 2,000 yards squared. So then the surface area, my base is 40 times 40, which is 1,600. The surface area will be the lateral area plus the base. So 2,000 plus 1,600 got me 3,600 yards squared. And then my volume, again, is going to be the base times the height divided by 3, which gave me 8,000 yards cubed. On number 3, my radius is 20 because it tells me down here my diameter is 40 miles, which gives me a base area, pi r squared, of 400 pi. So we just kind of tuck that away because we don't need that quite yet. But then the lateral area will be 2 pi r times the height, right? The circumference times the height, which gives me 440 pi. So my lateral area is 440 pi. To find the surface area, I had found those bases already, so I add on 2 bases, right, because it's a prism. It has a top and a bottom, or sorry, a cylinder with a top and a bottom. So lateral area plus 2 bases gives me 1240 pi miles squared, and then the volume, pretty straightforward, just base times height, will be 4,400 pi miles cubed. All right, on number 4, the one piece that you may have missed or you need to kind of notice, I want to point out, is that you do need to find this third side of the triangle, right? This is a triangular prism. We have 2 triangle bases. So this is 9, 12, and 15 for the sides of that. So the perimeter should be 36. The lateral area, 36 times the height, which is 19, would be 264. Surface area, 792. And the volume, since the base area is 1/2 12 times 9, which is 54 centimeters squared, the volume will be 54 times 19, right? Base times height. So 1,026 centimeters cubed. On number 5, this one is a rectangular prism. So I chose kind of this largest rectangle as my base, but remember that you could choose any rectangle as a base in a rectangular prism because all of those could count as a base because they're parallel and congruent. So that said, you may have a slightly different lateral area than me, but your surface area should still be 556 meters squared, and then the volume should be 680 meters cubed, right? So you should end up with the same surface area and volume, even if your lateral area looks different, because you may have just picked a different base and perimeter than I did. On number 6, because this is a regular hexagon, you can see that all the angles are congruent and the sides are congruent. You may have actually had to do a little bit of work to find that height. Oh no, actually it's right there. I apologize. So you actually do have the height of that. So the trick here is actually remembering the formula for area of a hexagon. So it would be 1/2 apothem times perimeter. The perimeter, it tells us that this side is 4 feet. So 4 times 6 gives us a perimeter of 24, which I have written up here actually. So the base area of that hexagon will be 24 squared of 3 feet squared. We don't need that for the lateral area, so it's just the perimeter times the height, so 72 feet squared, which I have down here. The surface area will be the lateral area, 72, plus 2 of those 24 root 3 bases. So I left those just kind of without simplifying because the instructions had said to leave it, without multiplying it out or anything. But if you did go ahead and multiply by the square root of 3 and add them together and get a decimal, that's fine. I think it's going to be somewhere in the mid 100s, probably like 100 and, I don't know, 30 or 40 something. So that's fine. And then your volume will be 72 square root of 3 feet cubed. Number 7, we're finding surface area and volume of spheres. So on number 7, we have a radius of 7. These should be pretty straightforward, right? Pi r squared, we get 196 pi inches squared. 4/3 pi r cubed. I got 1,372 divided by 3 pi. If you went ahead and plugged that fraction into your calculator, you would get something like 457.3 pi inches cubed. Don't forget to cube your radius, not square it. On number 8, since the diameter is 24, we have a radius of 12. Again, our surface area, 4 pi r squared, would be 576. And then the volume, don't forget to cube your radius, 12 times 12 times 12, will be 2,304 pi inches cubed. On number 9, we have a radius of 7.8. Don't forget to use your radius instead of the diameter. Surface area, 243.36 pi inches squared. And then for the volume, I got 632.736 pi inches cubed. So again, make sure you cube your radius there. All right, on number 10, we're finding surface area and volume of composite figures, which again, this can be a little tricky on the surface area. So I started by finding the height of my triangle. Since this whole width was 48, I know this kind of half piece here is 24. This is actually a Pythagorean triple, so you can use the Pythagorean theorem as always, or if you recognize it's 7, 24, 25, the height is just going to end up being 7. So I just kind of started with that because I knew I was going to need it eventually, but I actually don't need that until the volume. So when we go to our perimeter of this bottom shape here, the perimeter of the square or rectangular prism here is 192. So the lateral area of the prism will be 2,400 centimeters squared. Sorry, that's of the pyramid. The prism would be 3,456 centimeters squared. The lateral area of the pyramid is the perimeter times the slant height, 25 divided by 2, which is 2,400. And then the base area down here, which is 48 by 48, is 2,304. So again, for our surface area, we're adding together this bottom square, the lateral area of that prism, and then the lateral area of the pyramid, but we kind of ignore this square that's in the middle here because it's not on the outside. So 8,160 centimeters squared. For the volume, again, we can just find the volume of the pyramid, find the volume of the prism, and just add them together. It's kind of a big number there, though. It's 46,848 centimeters cubed. Okay, one note about 10 also before I go forward is that the diagrams aren't to scale necessarily here. So just notice like in number 10, I thought for the volume that the volume of the cone or the pyramid versus the prism looked a little off to me, but when I double checked my numbers, the numbers are correct. So I wish that we, could visually check perfectly, but these diagrams are just not quite to scale here. So notice in number 11, again, I went and found the height of my cone up here. So this is actually a 5, 12, 13 triangle, or you could use Pythagorean theorem to find the height. Don't need that yet for my surface area. So again, I started by finding the area of my base, 25 pi, and then I know I'm going to need the lateral area of this cone up here and the lateral area of the cylinder. So I found both of those right here, 65 pi and 20 pi, added them all together and got 110 pi centimeters squared. For the volume, all I needed to do was find the volume of the cone and then the volume of the cylinder. So my cone was 100 pi centimeters cubed, my cylinder was 50 pi centimeters cubed, add them together, 150 pi centimeters cubed. All right, number 12 is kind of a fun one, and I've had a lot of students like convince me that there are different or better ways. So if you have a different or a better way, you rock, and I'm glad that it works for you. I'm going to show you what I did. At the end of the day, your surface area and volume should match up with mine, and if they don't, then you might want to double check your method. So to find the surface area, I know I'm kind of all out of order here, but to find the surface area, I actually started by just saying that this shaded area here was my base, right? Because I have one here, and then I could sort of visualize that I have the other parallel and congruent shape on the other side of this prism. So I found the total perimeter, so 7 plus 8 plus 4. I found out that this length is 5, right? Because if this is 3, this will have to be 5 to make a total of 8. And then this guy would have to be 3, because 3 and 4 make 7, right? So my total perimeter of this shaded base that I've highlighted here was 30 centimeters. And then if I just do 30 times 10, that gives me a lateral area of 300 centimeters squared. So that's just the lateral area. I also have to find the two base areas to add them on, right? So my base here, the way that I did it here was I actually found the larger sort of area. So 7 by 8 was a 56, like this whole entire rectangle. And I just subtracted this smaller rectangle up here, which was 15. So that got me a base of 41 centimeters squared. But you could also have found like this is 3 by 7, right? This rectangle right here. And then this rectangle right here is 4 by 5, so that would be like 21 plus 20, which is still 41, right? So there's a lot of different ways to find this base. Once you find the base of 41, then you can just say, okay, the surface area is lateral area, 300 plus 2 times the base, so 382 centimeters squared. For the volume, since I already found a base of 41 centimeters squared, I just did the base, 41, times the height, 10, and I got 410 centimeters cubed. I've had other people in the past like explain that they found the smaller prism, this guy right here that I have sort of outlined, and then found the bigger prism and then subtracted them, right? 560 minus 150 gave you 410. Either way works, or if you did it a different way, as long as you get 410, you're golden. Okay, so this is another problem that is like totally a brain twister. So again, if you got this one right, awesome. If you're still feeling kind of stuck on it, it's okay. It took me a little bit of time to kind of work through it myself. So it tells us that the volume of this composite figure is 96 pi centimeters, and that should say cubed right there. And then it asks us what is the height, right? So it kind of gives us this h here. So there's a couple of different sort of h's or heights that we can figure out. So I'll explain that in just a minute. So what I started with was finding, okay, what do I know about the individual volumes of the two pieces here? So there's a sphere down here on the bottom and a cone on the top. So if I was going to find the volume of a whole entire sphere with a radius of 4, I would do 4 pi r cubed, 4/3 pi times 4 cubed, right? Simplify, simplify. A whole sphere with a radius of 4 is 85.3 repeating pi centimeters cubed. But I know I need half of that because this is just half of a sphere. So the volume of this half sphere right here is around 42.67 pi centimeters cubed. And that would be like a fraction version would be 256 divided by 6, or a simplified version of that. So again, 42.67 pi centimeters cubed, and this is a rounded value. The volume of the cone would be pi r squared times the height divided by 3. So since the radius is 4, it's 16 pi times the height divided by 3. But I don't know what the height is, right? So when I want to go back and say, okay, I know that I have a volume of 96 pi centimeters squared, well, that means my total volume that I know, right, is this kind of half sphere here plus this full cone up here. So I'm going to go and just replace everything that I know. So I know my total volume is 96 pi. I know this volume in my half sphere that I have is 42.67 pi. And I know my sort of partial formula or partial knowledge that I have of my cone is 16 pi h divided by 3. So since I see that I have a pi in each of these terms that I have in this equation, I actually just kind of mentally divided everything by pi, which means that pi sort of goes away in this equation, right? I could show my work by just writing divided by pi, everything cancels out. So now I have some nice numbers. 96 equals 42.67 plus 5.33h. And now this is just an algebra equation to solve for h. So I subtracted 42.67 on both sides. I got 53.33 equals 5.33h. And if I was sticking with fractions, I would get a perfect exact value of 10 centimeters. I got like 10.0005 or 2 or something weird because I was using decimals here because these are approximations. Using the fractions will actually get you exactly 10 centimeters for the height of the cone. The way I interpreted this question is that it actually wants the height of the whole entire figure. So if we took 10 for the cone and then added on another 4 centimeters for the radius of that sphere, the total height would technically be 14 centimeters. If you got here to 10, I am super proud of you and good job. And then, you can kind of decide how did you interpret it. I would take either answer. As I anticipated, this video got super, super long, but I want to have it here just as a resource for you guys. So I'm just going to go over one problem in the Chapter 11 test review worksheet, and the rest of it will be posted in Team. I'm going to go over question 8 from the test review worksheet. It tells us that the surface area of a sphere is 100 pi feet squared. What's the volume? So again, I know that the surface area formula is 4 pi r squared, and I know that my given surface area is 100 pi. So I'm going to sort of just ignore my feet squared for now, right? So that I can kind of work through everything without looking at that. If I want to get r by itself, I'm going to have to divide both sides by 4 pi so that I get r squared by itself. So divide both by 4 pi. Pi divided by pi is 1, and 100 divided by 4 is 25. So my radius squared is equal to 25. If I take the square root of both of those sides, I get that my radius is 5 feet. Now that I have that radius of 5 feet, I can go back up here, plug it into my volume formula, and go through and simplify. 4 times 125 gives me 500 pi divided by 3 feet cubed. It doesn't specify how to leave your answer. So you could leave it like this. you could leave it as 166.7 pi feet cubed, or if you multiply that by 3.14, you'd get 523.3 feet cubed. And these ones are approximations, right? This one's more precise, but either one will work.